Welcome back to the farm, boys and girls. We're very glad you could be here. As you can see, there's been a lot of snow falling on the hills around the farm just now. We thought you would like to see them. We've got lots of science to explore today. I think we should get started now. So obviously, as you can see, we've had a special type of precipitation overnight. That is snow. But precipitation is anything wet that falls from the sky. Rain, hail, sleet or snow. And the precipitation that we've just had is snow. Let's have a closer look at the word. The word is a very long one, but very simple to understand. Remember, it's anything wet that falls from the sky. A lovely activity we can do when it's snowing is use palette paints like these ones to actually paint the snow. Let's have a look. The first thing you've got to do is create a model of something. I've made a little tortoise here. Then you can very happily paint your little snow model using your palette paints. Alternatively, you could make a simple frame with sticks or little pebbles and then actually paint the snow within your frame. So first we add the blue sky and the sunshine, some pretty green grass along the bottom, and finally add some pretty flowers onto your picture. As you can see, the sun's come out, the snow is still on the ground, so what better way to spend our time than investigating colour and light. Let's have a look how we do that. So these simple things were made with paper plates and some cellophane, but equally you could make miniature ones using cardboard from an old cereal box and some sweetie wrappers. Now what you'll notice is that the light from the sun is shining through the cellophane and leaving these cool colours on the snow. Now, you can use them just as a pretty artefact out in the garden, or you could hang them from the trees as well. What we're going to try and do though is demonstrate how we can do colour mixing using the primary colours, red, yellow and blue. And as you can see, when I've put those two half together, the blue and the yellow have made green. See? When I mix the yellow and red cellophane, you'll see that the middle stripe is a lovely shade of orange. So that's something you could try yourself, children, in your own gardens. So from that experiment, it's clear that the primary colours mixed together make the secondary colours. I decided to use the scraps that I had left over to make this one. This would be a lovely sun catcher to hang in your garden. Do you see how pretty that it looks on the snow? If you decide to experiment with colour and light like I have just now, I hope you'll send me some pictures of it. If, like me, on a cold winter's day, you look up at the blue sky and you wonder, why is the sky blue? That's something I think we should find out now. So in order to answer the question of why the sky is blue, it's necessary to think about a very famous mathematician and scientist, Isaac Newton. Now what he did was discover gravity using an apple, but apart from that, he also discovered the theory of light and how white light can be broken down into all the colours of the rainbow, called a spectrum. These glasses have special lenses in them, which are fantastic because when you look at a white light wearing them, the lenses break the white light into all the colours of the rainbow, just like Isaac Newton said. So I'm going to take them off now and let you see what I'm seeing through the lenses. So what you're looking at just now, children, is a plain white light bulb. And as you can see, that is broken down into all the colours of the spectrum. Another way of looking at the light spectrum is by using a white light torch and a variety of prisms. As you can see, as I'm moving the white light around, the prisms are breaking the white light into the various colours in the colour spectrum. Now that we've had a chance to see the colour spectrum in action, we need to return to the original question. Why is the sky blue? We're going to carry out some kitchen science again just now, and that will hopefully help us to understand the answer to the question. So now that we've seen how white light can be broken into the different colours of the rainbow, I wanted to explore whether this could be done the other way, whether all of the colours of the rainbow can be turned back to white. Now, in order to show you how this can happen, I've got myself a Newton colour wheel, which you could make yourself at home. It's on the back of a little spinning top, and what I'm going to do now is I'm going to spin it on the table and let you see how all the colours of the rainbow can transform back into white. Wow! In order to see the sky being blue in real life, I wanted to show you this experiment. In my glass here, I have got a very small amount of milk mixed with water and a torch that shines with a white light. And I'm going to shine it in the dark now so that you can see the sky, which is the liquid here, turning blue. The reason that we can see blue inside the glass is similar to the reason why the sky is blue. The sky is blue because of Rayleigh scattering, and the white fluid turns blue because of Tyndall scattering, which is a very similar effect. In the air, all around us, there are many, many billions and trillions of tiny air molecules. They're so small that we can't normally see them with our bare eyes, even though the air is full of them. The colourless light from the sun is actually white light. It is made up of all the rainbow colours: red, orange, yellow, green, blue, indigo and violet, all mixed together like we've seen earlier. All of these different colours have different wavelengths. As a result, when white light is refracted, it is separated into the separate colours, known as dispersion of light. So, the short answer, boys and girls, is that as the sunlight reaches Earth's atmosphere, it is scattered in all directions by all the gases and particles in the air. Blue light is scattered more than the other colours because it travels as shorter, smaller waves, and this is why we see blue sky most of the time.